This is a little bit of a controversial talk. It may or may not be what you expect. Anyways, whether you like it or not, agree or disagree, feel free to let me know on Twitter. That's my handle over there. What do you think about it? I'm curious to hear any feedback you may have. As I said, my name is Milen. I work for this company called Liferay. Anyone heard of Liferay? Okay, a couple of people. We do a lot of modular software, and I've personally been observing the works on JPMS or modular Java for the last several years. So just wanted to share with you how things looks like. Anyone in here who has tried Java 9 with modules already? Anyone looking forward to? Okay, a couple of people. Okay, so you may find this interesting. Now, a few things that we need to clarify before we get into details is what I mean by saying not new. Because a lot of people say, wait, what do you mean it's not new? It's old new. Well, it's not new in terms of a concept. It is new in terms of APIs and tools and all kinds of things that showed up that will show up in Java 9. But the concept of modularity is not new. Modular solutions have been around for a very, very long time, and during this talk we'll compare some of those to see where the Jigsaw fits. So why is the right time to talk about modularity in Java now? Let's go through the history a little bit. The first attempt to modularize Java was in 2005. Actually, it was earlier. I believe it was around 2000, but the only written evidence I could find is from 2005 with JSR 277. Then there's going to be, there was another JSR 294, and fast forward 2014, we have the JSR 376 with a bunch of JEPs attached to it. That is actually the thing that modularizes Java. That is the thing that Oracle is working on right now. You may have heard different names, so before we all get confused about names, JSR 376 is the specification for modularizing Java. It's also known as JPMS, Java Platform Modular System, and this is the abbreviation that I will be using through the slide. And the implementation of that is known as Jigsaw, which is a project that's developed under OpenJDK. All those are pretty much the same thing. People use them like interchangeably, so don't get confused on that one. So this is a picture I took a couple of years ago. I think it was 2015 or 2015 in Dyankov in Belgium. And someone wrote on the table, on the board, we'll be using Jigsaw in 2016. You see the answers. What I like a lot is this sentence down there, and I wasn't the one who wrote it. It says you can pry OSGI from my cold dead hands. And that's an interesting statement, and we'll see how it is relevant. So as you may know, Java was delayed a couple of times, and the reason Java 9 was delayed a couple of times, and the reason it was delayed was actually JPMS. It turns out that JPMS is so critical feature of Java 9 that they delayed the whole release because of that. And today, this is a screenshot I took today, we have 81 days until Java 9 is officially released. And you may be aware of the fact that there are things going on, like Oracle and IBM threatening to vote no. Anyone aware of what's going on with the works on the spec? No? Okay, so there is a little bit of a disagreement going on right now between different companies, but my bet is this is when you're going to see Java 9 being released, regardless of who's going to vote in which direction. So it is the right time for you to start thinking about it, because it's going to affect you whether you like it or not. Whether you're looking forward or scared of it, it's happening. So you better understand what's in it. So before we start talking more about modularity, there is this important question that we need to ask ourselves. And I think this is the fundamental question of all disagreement and all problems that we face now with JPMS and modular Java. What is modularity? Do you know what is a modularity? Anyone has an answer for that? That's what I figure. Because basically, it's like this. When they say a word, it means exactly what they want it to mean, neither more nor less. So everyone who uses the word modularity has something different in mind. They imagine modularity differently, they imagine the features of modularity differently, and so it is like saying that, oh, our modularity is the one and only, but then the other guys are like, no, modularity is like a totally different thing. So let's try to define this. And actually that's not too hard. We may not be aware of the fact that it's something like modularity maturity model was defined by Dr. Graham Charters back in 2011. And so he defined these 6 levels of modularity. Are you familiar with maturity models in general? Okay, so maturity models are basically showing like how either organization or product or something grows. It goes through different stages, and with each stage it gets more and more mature. So those are the 6 levels of maturity for modularity. So this level 1 is basically nothing, you don't have any modularity. Then level 2, you have the modules which are decoupled from the artifact. Then you have like modularity, which is decoupled from identity, loose coupling, devolution, and dynamism. So this is what Dr. Graham Charters defined. Now, another expert, actually what he did, he defined level 7. And he said, level 7 is Peter Kriens, and it's only available for people who are Peter Kriens. Anyone familiar with who Peter Kriens is? Peter Kriens is the main designer behind the most famous person behind the SGI framework, and he's been dealing with modularity basically all his life. So it's like if you're looking to know about modularity from the best expert, that's probably Peter Kriens. So Peter Kriens, in this book, Java Application Architecture, replied to that. Actually, he didn't write the book, he just wrote the foreword for the book. And in that foreword, he said that he generally agrees with the maturity model, except he would define it a little bit different. He would just go with 5 levels, call them unmanaged, managed dependencies, proper isolation, minimized coupling, and service-oriented architecture. So the concept is more or less the same, it just grouped a little bit differently. So when I was preparing this talk, I was like, which model should I go with? And I did what Java architects did, I invented my own. Okay? So this is my modularity maturity model. It's called buzzword compliant modularity maturity model, because this apparently is how we all develop software these days, is based on buzzwords. So you go to a conference, you hear that everyone's doing microservices, you go home and you do what? Microservices, right? You put them in. Oh, come on, containers, right? Everyone's doing. Anyone not doing Docker? That's what I thought. So yeah, this is how it works, right? We listen to people, the smart people tell us very smart things, and then we go home and start doing those things without even thinking about whether it makes sense in our use case or not. So, buzzword compliant modularity maturity model works like this. You have the monolith, the bad guy, then the composite, containers, discovery, and finally you have the microservices. So let's see how those are defined. So the monolith is the bad guy who is not aware of own dependencies. It doesn't have to be, because we have like one big bag of everything in it, right? So we don't care how the things depend between each other, because we just throw things in it, right? Then we get more mature, and we realize that we need to compose things out of different things. And this is where your application becomes to be aware of infrastructural dependencies. So you know that this artifact needs that other artifact, otherwise it's not going to work, right? But it's just like on infrastructure level. Okay, so now you mature even more, and you start being aware of functional dependencies. So you all of a sudden realize it's not the jar file that actually I depend on, but what is inside that jar file that I depend on, right? And then you start doing things like components, and those components are wired somehow and things like that, okay? So you're aware of your functional, not infrastructural dependencies, okay? Once you're there, the next logical step of maturity model is to realize that what you deal with is actually not dependencies, but requirements. So it's not that this thing depends on that thing. It's basically that thing requires a functionality in order to deliver its functionality. So now you don't have functional dependencies, but you have functional requirements and capabilities of functionality that you can connect to each other to get the work done. So that's totally different from like artifacts and components. And the final level 5 of that model is when you realize that those are actually dynamic, that those are not defined once and forever, that your idea of how components and different infrastructure elements work together today is not the same thing as they will work tomorrow or the day after tomorrow. That things will change, and you need to be able to adapt to that change. And this is where you start talking about dynamic things, which is commonly referred as microservices these days, which is actually a term that showed up in OSGI long before it became a buzzword. So let's see how we deal with that. Level 1 is the monolith, the bad guy, Java app, everything in, with everything was a class path. Now, well, actually one jar. So the level 2 is the composite, and how do we handle these things these days? Well, we use the generous help of Milen to assemble an application. So we basically tell those are my dependencies, those are my artifacts that I depend on, and Milen is going to put them on the class path for us. How do we go to level 3? Well, we have a nice frameworks for that. We have CDI, a bunch of other Java EE, we have Spring Framework. So this is the level where we do more abstract things. So we can say this component needs this other component and build a Spring context or whatever. Now, keep in mind that this, while this gives you level 3, it doesn't give you level 2 and level 1, let's forget it. It doesn't give you level 2, so you still need Milen, right? So you need like a combination of all those. Anyone willing to guess what gives you level 4? No? Because there's nothing. Because the only thing that is above that level is OSGI, which goes up to level 5. I mean, you can use other modular systems, like for example, JBoss modules or some other modular system, but in generally, OSGI is the de facto standard for modular applications these days. So, this is where JPM fits in. And you may wonder why it is so curly, and I'll go through that and explain that in more details. But the general reason why it looks like this is because the main decision, design decision behind JPMS, one of the main decisions was to keep it simple. So the idea that Oracle can introduce a modular system that not only works, but it's very simple and people will immediately fall in love with it and start using it like all over the place is very strong. So their main motivation was, it has to be simple. It may not do a lot of things, but it has to be simple. And we'll see how that result, in what that result. But first, let's look into what is a modularity from an application perspective. So this is your application. This is how it looks like. It's composed of classes, and they nicely work together with each other, right? Okay, so those are classes. Okay, that's not your application. It doesn't work like this. It's more like this. It has the Java platform, which has a bunch of classes. Then it has a bunch of libraries that you put on the class path that also has a bunch of classes. And up there is your application. Okay? And now, if you need to know which thing depends on what other thing, you don't. At runtime, basically, it's almost impossible to tell. It's a nightmare. So, how do we fix that problem? Well, a long time ago, this thing called OSGI showed up. And a bunch of smart people behind it said, well, we can fix that problem. Let's see how we do it. So there's nothing we can do on the platform level because we don't own the platform, so that stays the way it is. We don't care about that. But how the things are loaded? They're class loaders. Okay, so everything in here has to be loaded by some class loaders. So if we can put our hands on the class loaders, we can actually manage the way dependencies are established and things are being resolved. And so that's what they did. So they put a solution that depends on class loaders, and it allows you to build dynamic modular application in which you know exactly what is connected to what and what, in what way and why. So this part remains. All the modules, all the libraries that you need. So what's the solution for that? Well, it was a naive one. They basically thought, well, since we've defined a modular system that's so good, everyone's gonna fall in love with it, and people will start building modules out there, and so every dependency eventually is gonna become an SGI bundle. And if you're familiar with SGI, you know how well that worked. So, this is a quote from Peter Kriens, which describes, which refers to some comments that were made about JPMS. And he basically says, a lot of people blame OSGI for being so complex, right? And what they don't realize is that the modularity is a hard problem to solve. So the framework essentially reflects the complexity of the domain. It's not the framework, it's the domain that is complex. Okay? And now with GSR 376 or JPMS, a lot of people start to realize that, well, their applications are not as modular as they thought. And we'll see an example of that. So, how JPMS addresses that exact same problem? Well, they own the platform, so they make modules first-class citizens. And that's a good thing. You want to have a modular JDK, right? So, what did they do next? They said, well, now that we have this, that's a great solution for everyone. So, nothing more to do. We just used what we designed. So we designed it for a JDK, but you can use it for your own application the way it is, right? What about libraries? Same idea. Everyone's going to fall in love with JPMS, and everyone's going to be building modules, and the world is going to be a perfect place. Not so. But let's take a step back. All this thing here is what I'm saying is not new. It's not new because if you wanted to do modulars, you could do that before JPMS. That stuff down here, modularizing the JDK, is new. You couldn't split your JDK into modules before, now you can. But all this stuff here is something that you could have done 10 years ago if you wanted to. Except many people didn't care about it. And so, back to this quote, a lot of people starting now to discover now that JPMS enforces restrictions on how you build software, that, well, their applications are not as modular as they thought they are. The first people to discover this were frameworks like Spring and Hibernate and all those guys who had to really do a lot of work to adapt to what JPMS offers. So, why is simple not always the solution? Let me give you a visual of how we build software. We build software the same way we build products, right? We start with a material, and then out of that material we made an intermediate product, then out of that product another intermediate product, and so forth and so forth and so forth. So at the end we produce a product, right? And this is exactly the same way we think of building software. So if you think about this thing, you want to build this robot, right? And what you need is some tools, probably some software, some like hardware, memories and stuff, or computers and things like that. So let's say those are the things that you need to build that robot. Sounds about right, except for those things to exist, there need to be a lot of other things. Like you're probably going to have some tools, or some cables, or power plugs, or a bunch of other things. Okay? And now, what's wrong with this picture? I'll tell you right away what's wrong. It's an acyclic graph. It's beautiful and not real. Because if you think about this real case scenario that happens in the world, you would have to draw arrows between every single two entities in that diagram. Because those guys here, they definitely use computers to produce their tools. And they definitely use some software, right? So these arrows, if you want to model a real world, would actually have to go all the ways, right? But that's not how we operate in software. In software, we want to have things simple and clean, and so we abstract from the reality and define clean and beautiful pictures. And so we think of it like this. There's an entity, it offers you something, and there's a nice acyclic graph of dependencies, right? And when we build an application, we do the exact same thing. We have a bunch of artifacts. Those artifacts provide a bunch of functionalities, and then another artifact consumes those functionalities, and then we assemble the whole thing together and create an application, and we're good to go. Okay, with that model in place, and with that picture in place, and given the modularity maturity model, let's compare the two solutions. So, this is what you get on level 2. You need to decouple yourself from the artifact. So it doesn't matter where the whole thing is packaged in. So in OSGI, you use the standard jar files, and JPMS, you can use jar files or JMods, it's a new thing. And inside those, you define your module. So you basically, in OSGI, you would use the manifest.mf file to specify a bundle symbolic name and a version eventually. And in JPMS, you would use this thing called modularity for Java. Pretty much the same thing. So that's why level 2 is okay for both, because they decouple you from the artifact. It doesn't matter what your jar is called, as long as the module inside is properly defined. Let's go to level 3. So the first thing is, when you want to decouple now from the module identity, is to tell what is your export, what is it that you give to the world. So in OSGI, you would say export package, and give a package name, and this is what you provide to the world. And in JPMS, you would say in module info exports, which is basically the same thing. So that is pretty much equivalent. Now let's see the flip side of that. The flip side of that is the consumer part. So in JPMS, you have this keyword called requires. And so you basically say, now in order for me to function, I need that other module. So you don't say what part of that other module you need. You say, I need the whole module. And that thing existed, and it still exists, but it's like not discouraged in OSGI in a form of require bundle. So in OSGI, you could say, I require this other bundle, and it was equivalent to that. And that thing caused enormous problems over the years with OSGI. And I always struggle to explain to people why exactly this causes problems, until these two smart guys, Neil Bartlett and Kay Hubbard, draw that diagram, which clearly explains why this causes problems. So, this is the situation before in OSGI and JPMS. So, in OSGI, because you depend on package, so you have a bundle, package in bundle B, that depends on the package in bundle A. Right? And in JPMS, you have a bundle B that depends on bundle A. At that point, it's all okay, right? Doesn't matter, it's the same thing. Well, guess what? A year later, you decide that your bundle A is way too big, right? And it actually makes perfect sense to split it into 2 bundles and put foo in one and bar in another one, okay? And it's perfect refactoring that a lot of us do on a day-to-day basis, which is shift things in different places, right? So now you have A and A prime, 2 different bundles. So from OSGI perspective, B doesn't care, because B, this package of B depends on that package, and this package of B depends on that package, and it doesn't care in which bundle it is. What happens in JPMS? Now you have 2 bundles, A and A prime. And now your B still depends on A. And remember, there's no versioning in JPMS. So you still depend on a bundle, on a module that no longer contains the functionality that you need. So you basically say, I need A, but because you don't say why you need A, you need something that in fact you don't need, because what you need is probably here. And if you say I need A prime, then you lose this. So there's no way for you to get out of that situation except refactoring the bundle B to either depend on both modules or to split B as well into two different modules. So that is the problem with depending on module and not on what actually the module gives you. Okay? So in other words, imagine that the module foo provides power plugs. And what happens is, in an OSGI environment, you would just say, I need a power plug, that's you. You would just say, I need a power plug. And you don't care if it's foo or someone else that gives you the power plug, because that's what you need, the power plug. In JPMS world, what you say is, I require foo. I require this guy. Because I, as a developer, not the system, me as a developer, I know that foo produces power plugs. And I, as a developer, know that by the rules of JPMS, no one else is allowed to produce power plugs. Sounds ridiculous? I mean, you would never do that in a real-world scenario. But to keep things simple, that's how JPMS operates. So you depend on a module and not on what module provides to you, which is okay for JDK, because JDK consists of modules, but they're all released together, always by the same company. So Oracle themselves, the Java architects building Java platform, they will never face that problem, because they don't release individual modules, they just release the whole JDK as a whole thing. But you will. The next thing is version. So say this guy changes over time, produces different power plugs. In OSGI, you could say that, okay, my thing that I'm building here can use power plugs between version 2 and 3, right? In JPMS, you have no way of knowing that. So it's up to you, the developer, to know that you've put the proper module on the module path so that it can resolve. The system has no information about that at all. It's you that needs to know. Okay? So, final on that level is, how do you deal with transitive dependencies? So you have this thing that exports something, then you have another thing that uses that something, and then it says you that actually uses this guy. Okay? So in OSGI, you could actually say, for when you export your package, you can say that it uses something else. It's merely an information for the modular system to tell, if you wire things together, make sure they are wired to the exact same things. So now in JPMS, you have requires public. How's that different? It's like this. In this case, you just say, when I was building my computer, I used a power plug, and you may want to know what kind of power plug it was in case you want to repair your computer yourself, right? In JPMS world, you would basically say, well, I used something from this guy foo, and so now you transitively depend on foo whether you like it or not, right? So it enforces you to depend on something without even telling you why, okay? So that's why you have this level 3, which is kind of implemented in JPMS, but not really. Now, let's move forward. The discovery. So, what happens when you want to totally decouple yourself from modules and what they provide, but actually wire things by functionality? So think about it. Your computer, in order to work, it needs power plug to be plugged to the socket, right? So you depend on the power plug. Well, no, you don't. You depend on the power. You depend on the fact that someone or something can power up your machine. That's your functional requirement. It's not dependency on the plug, right? So imagine that you can just say, I need to connect my device to power. And then someone else, somewhere, can say, I can do that for you. I don't care how. I don't care if he's going to give me a power plug or just going to wire the things in some other weird way. As long as there is a power, my computer can work. Okay? And this is where the notion of resolver in OSGI framework comes from. It says, you tell me what you expect, and you tell me what you can do, and I'll make sure you guys can work together to solve that particular problem. So there's no dependency. It's not that I depend on you or you depend on me. So we both work together to solve that particular problem. There's nothing like that in JPMS. Now, JPMS is going to have to, at some point in time, deal with that problem, particularly when JEE starts building stuff on top of it. But for now, there is nothing that allows you to do this. I mean, you can probably work around it by custom coding some kind of things, but nothing that you get out of the box. So this is what you get on level 4. The very basic APIs that you can code around if you want to. Level 5, last one, is when you acknowledge things change. And at that point in time, you want to be able to replace one thing with another or change some functionality. And in OSGI world, artifacts are replaceable. So you can just get a bundle and put another bundle. Why is that important? Because those bundles, they don't really interact, they don't depend on each other on the bundle level, but instead they use this thing called service registry. So you put a bundle, and it registers in this abstract registry some services. And then another bundle is going to look into that registry and just say, give me something that can do this. I want, I don't know, something that logs messages to the console. Right? And the service registry is going to scan its meta information and say, okay, this guy claims, according to the contract, the interface contract, that they can do that. Right? And it's going to give you an instance. On the JPMS side, this will never work because the JPMS needs to resolve, well, resolve is kind of like, not a proper term, validate the status of the modular system before it actually starts, on startup. So when the JPMS starts, it has to inspect everything and say, good to go. If it discovers any malfunctions, it's going to crash the whole thing. Say, I'm not starting because your modular system isn't properly configured. Okay? So there's no way for you to acknowledge the fact that things may change tomorrow and adapt to that without actually restarting your whole application. Okay? So, your application, unfortunately, cannot do that. I mean, okay, to be fully honest, there is a notion of layers in JPMS, which you can dynamically create and then like delete. And so you can create a layer with a bunch of other modules on top of another layer and so forth. And this is what is expected to work with, this is what is expected to let things like Java EE work. But we are yet to realize how efficient and how good that API is, and so far no one is using it. So. Okay, so I told you a bunch of things that are not so good about the JPMS, and you may be thinking, oh, wait a minute, they did modularity wrong. I mean, how could they, right? No, they didn't. Remember that slide? That's what it is. Depends on how you define modularity. The goal of JPMS, even though now they claim it always being to provide a general purpose modular system, I still remember the days where the only goal of JPMS was to modularize the JDK. Right? And that's why they didn't want to base it on OSGI or any other framework, because it didn't serve the purpose of modularizing the JDK itself. And as such, as a solution that modularizes the JDK itself, it is a very good one. They managed to achieve almost all the goals that they had, which is like strong encapsulations, reliable configuration, and so forth and so forth. So from Java platform perspective, JPMS was the right thing to do. The problem is, when they decided that what's good for the Java platform, it's good for everyone else building Java applications. And that is implying the restriction and limitations and constraints that Java platform has on your applications. And that's something that you will have to deal with one way or another, whether you like it or not. That is why a lot of people seem to believe these days that that's actually a good thing, because now that every Java developer is forced to start thinking in modules, they will actually start looking into better solutions than the JPMS, and then they're going to come to OSGI world or JBoss modules or other module systems. I wouldn't be too optimistic about that, but it may happen. Okay, so finally, the final thing is, okay, you said that with Java you cannot go to level 5, but do I really need to go to level 5? Maybe I'm okay staying at level 2. So when do you need to mature, when your application needs to mature, so that level 5 is crucial for you? So, the essence of modularity is not knowing. The moment you acknowledge that you don't know, you need modularity. So anytime you build an application that you can say, I don't know how this application will behave tomorrow, 3 months from now, 1 year from now, you need modularity at one level or another. And this is the situation we at Liferay are. Is we build a product, which is a platform, and we give that platform to people, and that people build different kind of things with that platform. And we have no idea how people will use that platform. So at day one, we need to acknowledge the fact we don't know. And we need to be prepared to give those people the right tools for whatever comes to your mind. Okay, so give me a few examples. Liferay is a pretty big platform, and we spent the last 2 years modularizing it. It's still one platform, it's over 100 apps, over 600 modules, and well, that's pretty old information, though, it's probably more than that now. And over 2,500 microservices at the time I was doing this slide. It's probably more now. So when I say microservices, I'm saying independent components. Components that you can start and stop and install and uninstall. Not necessarily the microservices that you guys think about, which are RESTful services on individual JVMs and so forth. So those are disposable services that you can mix and match and use. So this is an example of how we implement, how we deal with RESTful services. Okay? So one thing we could do is we could say, let's use what is it, Jackson, or the default implementation, just stack that in the platform, and everyone must use this because we say so, right? And then we get a bunch of unhappy developers out there because they want to use different implementation. So instead, we use the requirements and capabilities of OSGI. So if you deploy a RESTful service on Liferay platform, all you need to say is that you require a capability. And that capability is an OSGI contract, and that OSGI contract is Java JAX-RS and version 2. Anything that can serve such thing is good for you to go. Now you can deploy another module that says it provides a capability. It's capable of satisfying the Java JAX-RS contract. It uses those packages, and its version is 2. Those two packages, those two modules, they have virtually no dependency on each other. They don't even know that they exist. Like one doesn't know the other one exists. They just say what they need and what they can do. Okay? And then it's the resolver that says, oh, you want to be able to serve RESTful services? Oh, this guy can, so I'll hook you up with it. Okay? So this is like the way we acknowledge we don't know what people will want to use in their production environments, and we give them the option to be as flexible as they can be. If you think it's much complicated because of the example before, and you have to write all those kind of weird-looking properties, it has a full annotation for annotation support, so you can use app component, but it's much like Spring. You define your components and you basically say what it provides, what it exposes, what services, and so forth. And consuming it is as simple as using a reference. And it's even better than Spring in the sense that you can say that you dynamically depend on something. So if this thing is not there, you will be notified it's not there, but it won't be, your component will not be stopped. So you're given the option to deal with that the best way for you. Okay? So, acknowledging that you don't know enforces optimization for predictability. Obviously, you can't predict everything, but what you need to be able to do is think ahead and say, okay, maybe there need to be extension points at these places so people can actually do stuff with that. Okay? And when you start doing that, when you say not knowing and predictability, does it remind you of something? Well, that's exactly what we talk about when we talk about Agile. except we apply Agile to processes and not to software. So while doing this, you're basically making not your process, but your software Agile. You make your software able to adapt to upcoming changes, okay? And that is when you need level 5. Okay, that's pretty much all from me. Shameless announcement, we do have this conference coming in October in Amsterdam, so if you want to learn more about modularity or Liferay, or you want to talk at this conference, feel free to submit some call for papers, still open. Hope you learned something. Tell me whether it was useful for you or not on Twitter, and thank you.